Good day. In this particular lesson, we're going to look at finding the equation of a regression line. We kind of talked about that when we were talking about calculating the correlation coefficient, which was KK11 for this year. However, instead of looking for the correlation, which is represented by R, we're looking for the equation of the line of best fit. So if you remember when I showed you the chart that had the lines and the data that was a scatter plot, we're looking for the equation of that line that goes between the dots. So let's get right into it because we're going to use the same calculator skills that we used previously. So we've got our first question. It says, find the equation for the least squares regression line of the data described below. Ava is a novice cook trying to perfect her baked potato recipe. She decides to put many potatoes in the oven and invites all of her friends over. Every few minutes, she takes a potato out of the oven and asks some friends to rate its taste on a scale from 1 to 10, where 10 is excellent. For each taste, Ava writes down the number of minutes the potato spent in the oven, which is X, or our input, our domain, as well as its rating from 1 to 10, Y. So the rating is the output. So I eat the potato, I tell her what I think. And that is our output or our range. Okay, so we're told to round our answers to the nearest thousandths. And notice this looks like Y equals MX plus B. Well, this Y hat is something you're going to do in statistics. So pay close attention to this because you will use it again. So we're going to go ahead and go to add lists and spreadsheets. I went past it. Hit enter. I'm still just going to use X and Y because it would take me too long to type in the other things, but you may type them in if you like. And I'm going to type in my Y. And I place in my X and my Y. Come on down. Let's see a greater, so that's good. Now, here is my slope, and here is my y-intercept. So my slope, I'm going to write this number here, is 0.0869. So I'm writing to the 10,000ths place here. And then my y-intercept is 1.1236. So here I want to round to the thousandths place, and I'm going to use the 9 to determine what this number should be. Well, the 9 is greater than 5, so I'm going to round this 6 up to the next number. So this, my slope would be 0.087. And I'm going to do the same thing here. I'm going to use the 6 to determine what the 3 should be. So this would be 1.12. Now the 6 is greater than 5, so I'm going to round the 3 up to a 4. So 1.124. And that would be our answer. Let's go ahead and take a look at the next one. So again, we're asked to find the equation of the least squares regression line of the data described below. Cindy notices that everyone in her class reads at different speeds. She wonders if a person's reading speed is related to the number of books he or she reads. And you may be thinking, oh man, causation, right? Yeah, surely. It has to have some bearing. Well, let's see. Cindy asked a few students in her class how many books they read last month, X, and times how long it takes them to read the same paragraph in seconds. So here we have the data that she collected. Books read last month, which is our X or our domain, or our input. Seconds needed to read the paragraph. This is our output, our range, or our Y, right? So we're just going to do what we did before. Let's go ahead and put our data in. So we go to Add Lists and Spreadsheets, hit Enter. We'll use X. And then I'm going to come up and put my information in my Y column. And then menu, statistics, stat calculations. I want a linear regression. I'm going to change my X list to X, my Y list to Y. Make sure that my first result column is C or anything greater than C. We look good. Hit enter. And here is our slope. It is negative 1.7842. And then our y-intercept is 79.9644. And this is what I was telling you right here. This is a very good example. You see how they have already rounded it? If you use this, then your answer will be wrong, because when you get ready to round to the nearest thousandths, you'll be thinking, oh, I should round up to 5 because this is 5 and this is 4. But if you look down here, the number hasn't been rounded already. That's why I want you to use the numbers down here. So we've got negative 1.7842. We use our 2 to decide what our 4 should be. 2 is less than 4, so we're just going to drop this 2, and we put in negative 1.784. Now here we have 79.9644. We're going to use our 4 to determine what this number should be, and it is 4 is less than 5, so we're not going to round up, we're just going to drop that 4, and we've got 79.964. And we are done. Please, please, please ask if you have any questions, and I'd be more than happy to help you.